Ponce. I work for Gerrit Forge again. I'm glad that I'm coming after Patrick because the topic I'm gonna talk about is quite related to performances. And actually it's like, I'm gonna present you a tool to measure client-side performances. So it's quite related to what Patrick was talking about. A normal question that I usually need to answer to, well, the community and to our customer is like, okay, we're gonna upgrade to a new version of Gerrit. Okay, are we gonna get anything better in terms of performance? Or what if I change this configuration? Do we have any impact in the performance of Gerrit? Or how many times a day I need to run GC to keep our performance steady? So these are the common questions that usually we need to ask ourselves, and I need to answer to our customer as Gerrit Forge. So how did I do until, let's say, 6 months ago, more or less, when I started working on Gatling? Well, I was using benchmarking tools, so I listed a couple of them. They were good enough at the time, so they're good to generate traffic. They are benchmarking tools, so that's what they do. The problem with them that they don't really have any detailed client metrics. So you get an overall idea of what the response of your server can be, but yeah, you can't really drill down in detail. And they don't handle complex scenarios, so it's really difficult to try to simulate the traffic that you really have in production and maybe replay it in your staging environment, for example. And another limitation is they only support closed model, so they don't support open model. So I thought, like, okay, I probably need a better load testing framework. I've used one in the past that I quite like, and it's open source, which for me is a big plus. And it's written in Scala. Don't get scared about that, but well, I'm a Scala developer. I quite like the Scala language, so for me it was ticking all the boxes. The tool I'm going to talk about is Gatling. What is Gatling? So this is if you land on the Gatling page, this is what you get as a presentation of Gatling. And I want to focus on a couple of points. Gatling is easy to use and maintainable. It supports the HTTP protocol. It's protocol agnostic, and it has a really expressive DSL. So in this presentation, we're gonna dig in these basically 3 topics. So we're gonna start with the support of the HTTP protocol and the protocol agnostic. So it is true that Gatling only implement natively HTTP protocol. In fact, it's really powerful whenever you're testing REST API, for example. But the nice thing is that it's possible to reuse the Gatling engine, which is the one producing all the stats client side, and it's super powerful, and we'll show you some example later on. So Gatling has some extension points, so you can extend it and implement it in protocol. So that's what I did. So I just written a Gatling extension implementing the Git protocol. And then just using the cool matrix engine provided by Gatling. And that's it. And then as Gerrit Forge, we started to publish our extension, and we started to use it. And you can also find it on the Imavert Central, and we are also on the official Gatling page among the active extension of Gatling. Now, the other 2 points I want to focus on is the maintainability and the expressiveness of the DSL. As I said, Gatling is written in Scala, but thanks to the expressive DSL, it doesn't really matter the language because it's quite self-explanatory. So I'm going to show you an example of a load test. So what this load test is doing is basically loading some data from a feeder, from a file, where you can define your request. And then here is where you build your scenario. So you just give your scenario a name, easy. You just tell your load test to run forever. You just tell your test where to get the data from. So you tell your test where the feeder is. And that's it. And that's what you are executing. So you're just, and here basically we are hooking into the Gatling-Git extension. And this is the part of the setup. So here you define your profile. So in this case, it's a really simple profile. We're just saying, just hammer my server with 5 concurrent users. So nothing fancy. And this is the duration of your test. In this case, 1 minute, not really meaningful. But. And this is how the file looks like, the feeder looks like. Really simple. In this case, we just have clone. So you have the URL that you are hitting of your repository and the command. In this case, it's just a clone, but you can have a push, you can have a fetch, you can specify a different ref spec if you want. So if you want to get a particular change, yeah, no problem, you can do it. This is another example of scenario. So this scenario is basically hitting some Gerrit APIs. So in this specific case, what I'm doing, I'm creating a with change. So what I'm doing here, I'm just saying, okay, this is an HTTP request. Just post it to this URL. This is the header that I want to inject. This is the username and password for basic authentication. And this is my body. That's it. Easy. And these are the checks that I want to do on the response. Despite being Scala code, it's quite expressive. So you don't really need to be a Scala expert to write a scenario. So these are our metrics of Gerrit.io. Just to make Luca happy, I'm going to run a load test in the production environment because I trust it. So the load test is really simple. It's going to be a bunch of clone and fetch against a couple of repositories. And as you can see, Gatling just started now. And you should see here that the traffic, there you go. So in this case, I'm just running the test for 3 minutes because it's a demo. But I will show you later that at the end of the load test, a report will be produced, which is really similar to this one. So this is how a Gatling report looks like. So you have a first global tab here and the details tab. So the first global tab gives you an overview of your load test as a whole. And you have different metrics you can have a look at. For example, if you can drill down, you can have an overlook at the I don't know, total number of fetch in this case, or total number of clones with some response time, 99 percentile, etc. And the same metrics that you have for the global view, you also have on the detail view. So if you have, like in the case of this scenario, I'm running fetches and clone. So if I want to drill down only on the metrics about clone, I can just click on this tab, and I only have the metrics regarding the clone. And I can, for example, have a look at the distribution of my response time just for the fetches or just for the clone. So as you can see, the clone, they have a different distribution. So it's really cool, and it's really powerful, the metrics engine. And that's what we did with the Gatling-Git extension. We extended the protocol, and we hooked into a report engine. So while I was talking, my test is finished. As you can see, we created quite some load on the server, so roughly 200 clone and about 100 fetches, which is, well, if you consider I'm running it from my machine. And Gatling, as I said, at the end, it just create a report that you can open and you can easily explore. Functional tests. So when I show you the code, I show you that it's quite easy to write, functional testing in Gatling, even though it's not the appropriate tool. But since I started to work with it and I was like, okay, I have all the machinery in place, why not misusing it a bit and using as to write some functional tests? So that's what I did. So I created some, for example, we use it for Gerrit Hub and we use it with some clients. So I started writing these functional tests to simulate, for example, a login of a user or to check the Jira integration, which, for example, when you create a change commit with and without a ticket, the Jira integration responds properly, or I just simulate a private workflow or work in progress workflow, or any other complex and critical user workflow, which might depend on your user base. How to integrate it in your software life cycle somehow. So we know that load tests are hard, are time and resource consuming. So you want your integration to be as smooth as possible to make sure that people actually use them. Otherwise, yeah, you have this nice tool, but it's there parked in the garage and you're not really using it. As usual, Docker is your friend, so it's really easy to Dockerize your load test. So what you can do, instead of people coming to you and say, can you run this load test for me? You can say, no, the Docker image is there, you run your load test. And you don't need to install anything apart from Docker. Jenkins has quite some nice integration with Gatling, has a couple of plugins that provide quite nice graphs, which I will show you later. And it's quite easy with Jenkins to scale the load, because at some point, if you really want to create a meaningful number of load on your server, one single laptop is not enough, and also you want the load to be distributed. And again, it's really easy with Jenkins to orchestrate the workers, and in particular to publish the report. So what you can do in Jenkins, you can treat the report as an artifact of your load test. So you can ideally run daily your test in your environment and see that there are no performance impacts. Coming soon, something that we've been working on during the hackathon last week is the integration of the load test in Kubernetes. So the idea is that if you have a Kubernetes cluster somewhere, you can leverage it to run your Gatling load test using Kubernetes. And the long-term plan would be to integrate this load test in the Gerrit CI pipeline. Of course, not for all the changes, but maybe for like release candidates and stuff like that. So that's the long-term plan. Nice integration that you have with Jenkins are these graphs that show you the trend of your tests over time. So at a glance, you can understand if you have a degradation of the performance over the different runs. And this is what I was talking about before, the publishing of the load test result as an artifact. You can run your load test from Jenkins, and you can have the result in Jenkins as well, so you don't have to go to other tools to see the result of your load test. During the hackathon last week, we ran some load tests against Gerrit version 3.0 and version 3.1 because we wanted to provide a real use case, and we wanted to see if actually we were going in the right direction of improving performances. And it's always difficult to run a load test which is meaningful, because usually you go, okay, I have a staging environment which is really similar to production, but yet it's not the production environment. So what we did, we deployed, we upgraded straight away as soon as we released 3.1, 3 other servers in version 3.1, and we left just only one in version 3.0. So that we can test basically the 2 versions in production, which is the closest way you can get to have a test in production. So the test I did was a really simple test, stressing the API in this case. So what I did, I just create 100 changes, chained one to another, and then I submit all the changes together. And I compare the performances on the 2 versions. And this is what we got. So this is 3.0. So you can see the first part here of the graph. the creation of the change set. And this peak here is the merge of all the patch set together, which is quite impressive. And if we look at free one, that's what you get. Well, you can see that it's definitely way faster, at least twice as fast in terms of time spent for each change set creation. And of course, the overall scenario was quicker, so we have like 8 minutes versus 14 minutes. So it looks like we are going in the right direction. And now let's see at the same. Let's have a look at the same matrix but client side. So as I was showing you before, you can in Gatling you can drill down in your scenario, and you can have a look at the breakdown of the step of your scenario. So in this case, I'm focusing on the creation of changes, because are the one that in this particular scenario have the most statistical meaning. Yeah, you can just select the part of the scenario you're interested in. You can have a first glance a look at this report, and from here we were already seeing that the improvement was quite massive. So let's say 5 seconds versus 3 seconds on average, which is pretty impressive. And you can also have a breakdown of the distribution of your response time. And as you can see in the two versions, the distribution is pretty similar, but if you have a better look here, the scale are different. So that's basically twice as fast, roughly. So yeah, I was quite impressed. Okay. Can you create mixed scenarios with both Git and HTTP protocols? Yes, you can, but I don't know if you recall in the very first example, at the end of the code, there's a part where you can define your scenario, and when you define your scenario, you define the shape of your scenario, so it can be, you can have like ramps or like constant user, but you can also define the duration of your scenario, and you can also define the protocol that you want to use for your scenario. So yes, the answer is yes, you can mix it up. And in the report section, you can even filter by different protocol if you want to drill down in a specific performance. Can we host Gatling-Git on Gerrit review so that we can also use the Gerrit REST API Java library? I don't see why not, as long as we keep it generic for any Git implementation. I'm more than happy to do that. Can you create a massive load of incoming, create change request using the Git protocol? You can. So the easiest way is to, as I was showing, well, the easiest way until now I managed to create it is with Jenkins, basically. So in Jenkins, you can have, you can distribute the load among different, several, executors, and that's the easiest way you can do it with. And you can do it either creating the changes using the REST API or the Git protocol itself. It's up to you. What would need to be done to support Git wire protocol v2 in Gatling-Git? Would it be enough just to implement Git wire protocol? Yes, the answer is yes. So Gatling-Git uses JGit behind the scenes. So once the v2 implementation of the JGit client will be available, yeah, on Cascade, Git Gatling will benefit from it. How do you collect results produced by different Gatling executor? The nice way of doing it is in Jenkins, basically have a separate job that is aware of the, of the executor where you're running your load test, and just go fetch fetch all the artifacts of each run, and run and basically create the results out of it. Now this is the nice way of doing it. It's a bit tricky in Jenkins, I have to admit it. So the first step is manually download all the simulation. The Gatling basically produces a file which is simulation. It's called simulation.log, which is anything that is needed to everything that is needed to produce a report. And as a first step, you can start just by downloading all the simulation.log and just running a Gatling command, which I can show you later if you want to. And that's it, the report will be produced. Did you ever manage to break Gerrit User? Yeah, I was trying during the presentation, but I didn't manage. No, but jokes apart, depends what you mean by break, but let's say that we intensively stress, in particular, the heap, particularly when you are playing around with GC settings to simulate high peak traffic and understand how you can set your parameters for the GC collection in Gerrit. I've integrated with your CI, so partially in Gerrit Hub IO and fully to some customers. Fully integrated. When I say fully integrated, I mean that whoever wants can just go in Jenkins and say, I don't know, run this particular load test with, 20 executor for X amount of time, and that's it. And Gatling will go and do it and produce the report. So that's. Can we run Gatling test again every commit merge on Gerrit? Yeah, it would be a bit lengthy, a bit expensive, but yeah, theoretically yes. Maybe we won, maybe not against every merge commit, but
we have quota enforcement on Gerrit review. Go ahead, punk, make my day.
Can you do SSH-based testing as well?
Theoretically, yes. We don't, because the way you would do it would be basically you would have to implement another Gatling extension for the SSH protocol, and it's not. I did check as well, but it's not available yet. So I decided, okay, where do I go, SSH or Git? Well, I started with Git. But yeah, it's in my mental pipeline.
The performance improvement factor 2 in 3.1 compared to 3.0. Do we have a good explanation for that? It is all Matthias fix for time resolution, or what it is?
Definitely. So I keep saying it, but the performance is a million small things, right? And so one of these small things, or bunch was probably what you see.
The interesting thing is that now in the use case I just show you a load test that we run against the API. So, but we also run a load test leveraging the Git protocol itself, and it basically show us more or less the same kind of improvement. So that's pretty cool, because however you create a change, however you you do an upload path, basically you are faster. And the next thing I would like to test is the ref table one. So that's the next candidate. Yeah. Yeah. So, thank you.